Okay, fourth graders, today is Thursday, January 16th, and today we're continuing along in Module 5. We're doing Module 5, Lesson 11. And today we're still thinking about making equivalent fractions or making fractions that are renamed in different ways but still have the same value, right? And today we're going to use lots of different strategies. We're going to be using a tape diagram. We are familiar with those. We're going to be using a number line. We're going to be using multiplication. And we're going to be using division. So we have to show in multiple ways how two fractions are equivalent. Does that make sense? Good. Let's first talk about the problem of the day. So here we can see we have a tape diagram where the entire thing is 1, right? And a fraction of that 1 whole is shaded in. What fraction is shaded in, by the way? 1/3. Now right under it we see a number line. We know that number lines are lines that go on and on and on, and as we move to the right the value gets bigger, and as we move to the left the value gets smaller. Now the directions tell us to label the number line with the fraction shown on the tape diagram. So we can see if the entire tape diagram is 1, then by the time we get over here this must be 1. Do you guys agree? And down here at the very beginning of the tape diagram that must be 0. Okay, draw a number line underneath. Now we can see tick marks. That's what these little lines are called on the number line. This first tick mark must represent what fraction based on the tape diagram? Everyone? 1/3. 1/3, good. And then the second tick mark then must represent 2/3. What would the third tick mark represent if we were talking about thirds? We have 1/3, then 2/3, then everyone? 3/3, which is the same as 1. Then the directions say to circle the fraction that labels the point on the number line that also names the selected part of the tape diagram. So what part is shaded in on the tape diagram? Everyone? 1/3. 1/3. Let's go ahead and circle 1/3. That's how you do these kinds of problems. Let's try another example. Again, we see a tape diagram. We know that the entire piece of tape is worth 1. So we can label that on the tape diagram already. Down here is 0. And right here at the end of the tape diagram would be 1. Now this time our 1 whole is divided into how many equal-sized sections? How many units do we have, everyone? 6. So that means the first tick mark shows 1/6, then 2/6, then 3/6, then 4/6, then 5/6. How many sixths are shaded in? Everyone? 2/6. So that's what we would circle on our number line. Now we could use these tape diagrams to show that 1/3 is equal to 2/6, because if I were to group these together, would that be the same? The number line also shows it, right? Because if I were to add tick marks here, wouldn't 1/3 be equal to 2/6? So these pictures show us that we could use tape diagrams and number lines to show that two fractions are equivalent. In this case, 1/3 is equivalent to 2/6. So these are the same tape diagrams and number lines from what we had before. Do you see that? Yes? Are they the same? So what number sentence could we use? Should we use multiplication or division to show that both are correct? We actually could use both. We could use multiplication by writing that 1/3 equals to 1 times what? 1 times what if we're trying to equal to 2/6? 1 times, everyone? 2. All over 3 times 2. And this number sentence shows that 2/6 is equal to 1/3. We're really multiplying 1/3 by what version of 1? Haruto? 2 over 2, very good. We could also use a division sentence. We could say that 2/6 equals to 1/3. And how could we use division to prove that 2/6 is equivalent to 1/3? Varshini?
2 divided by 2.
All over?
6 divided by 2.
Very good. And in this case, we're really dividing by a version of 1. 2 over 2. Do you guys see that? So you need to be able to use a tape diagram, a number line, multiplication, and division to show that two fractions are equivalent. In this case, we are proving that 1/3 is equivalent to 2/6. 2/6. 2/6. 2/6. Do you see how we do it in 4 different ways? Very good. When the direction asks us to draw a number line, we draw a line, with arrows that show that this number line actually goes on and on and on, but right now we're only looking at this portion of it. Then it says partition it from 0 to 1. So you're going to have 0 on one side and 1 on the other side. And it says to partition it into fourths. That means I need to cut the space between 0 and 1 into how many equal size units? 4. So I'd like to do 1/2 first, then the fourths. Then it says decompose 2/4 into 4 equal lengths. So here, let's label. Here would be 1/4, 2/4, 3/4, and of course 4/4 is equal to 1. Now it says to decompose 2/4, and here is 2/4, right? So we have to decompose the distance from 0 to 2/4 into 4 equal lengths. Right now, how many equal lengths are there between 0 and 2/4? Show me with your fingers. There are 2. How many are we trying to get it to? 4. So we have to go like this, right? Now there are fourths. Now there are 4 equal lengths from 0 to 2/4. If I were to do that, how many units am I splitting really between 0 to 1? How many units am I splitting for 0 to 1? Are enough? 8, right? So this shows me that 2/4 is equivalent to how many 8s? 1, 2, 3, 4. Do you guys agree? Then it says to write a number sentence using multiplication to show that 2/4 is equivalent to 4/8. So how could I write a number sentence using multiplication to show that 2/4 is equal to 4/8? See if you can write it down. Go. We can do it by writing 2 over 2 all over 4, 2 times 2 all over 4 times 2. Then for step 4, it says to write a division sentence to show that 4/8 is equivalent to 2/4. We can, of course, show that by doing 4 divided by 2 all over 8 divided by 2.